Part 2b, the causes of glaciations and interglacials within ice ages. One other possibility for the onset of ice ages is the Milankovitch cycles, discovered in 1920 through the painstaking research of Milankovitch. These cycles plot and forecast the glaciations and interglacials within ice ages, but it is possible that these cycles could reduce greenhouse levels enough to kickstart a major ice age, but that's not likely. In any event, three global movements occur that are repeated in continuous cycles through the course of thousands of years, and all three are caused by the gravitational influences of the Sun and the other planets. Each cycle has its own independent duration, and each cycle affects the amount of solar radiation that the Earth receives, thus determining whether the Earth is in a cold climate period or a warm one. The three cycles are the Earth's eccentricity, axis obliquity, and axis precession. The Earth's orbit around the Sun varies in shape, and this fluctuation is its eccentricity. Over the time span of 93,000 years, this revolution alters slowly so that our world's orbit around the Sun changes configuration from nearly circular to slightly elliptical. At this point in time, the present, the Earth's orbit tends toward an elliptical shape, and during perihelion, at the beginning of January, we are 3.2 million miles closer to the Sun than at aphelion, which occurs at the beginning of July. The difference in miles equates to 6.8% more solar radiation at perihelion than at aphelion, and it also makes spring and summer in the northern hemisphere a few days longer than autumn and winter. At its greatest elliptical shape, the Earth will receive about 23% more solar radiation at aphelion, although perihelion and aphelion seem to be reciprocals of each other. However minuscule the difference is, the Earth is detectably cooler while in a circular orbit. We are slowly creeping toward a more elliptical orbit, and we should be there in about 10,000 years. And at that time, Earth will be closest to the Sun in July. Obliquity is the measurement of the Earth's tilt on its axis. This axis varies between 22.1 degrees and 24.5 degrees. Greater tilt angles mean more extreme seasons, and smaller angles mean cooler summers and warmer winters. In other words, the lesser the tilt, the cooler the planet. The obliquity cycle takes about 41,000 years to complete, and the Earth's tilt is currently 23.4 degrees. We are currently moving toward a more severe tilt that will occur in 9,800 years. The Earth has fluid oceans, a fluid core, bulges, and other planets pulling on it. All the while our planet is rotating on its tilted axis. These influences give our world a secondary turn around its axis. In other words, the Earth is engaged in a compound movement. 1. A simple turn on its axis. 2. The axis is turning as if it were a straw that you are using to stir your drink. This stirring of the axis is called precession. Precession points the Earth toward other heavenly bodies, including the Sun. Oddly enough, precession moves in a predictable cycle that takes about 25,770 years to go full circle. Currently, the angle of Earth's precession is moderating the seasons of the northern hemisphere and causing more severe seasonal fluctuations in the southern hemisphere. This situation will be reversed in about 13,000 years, and the southern hemisphere's seasons will be milder, causing the cooling of the southern oceans, paving the way for a global temperature drop. As I mentioned earlier, Milankovitch cycles may cause glaciations and interglacials within ice ages and predict future events to strong probabilities, but individual cycles cannot make the climate changes that can result from continental drift and mountain building. However, if Earth's orbit is at its most circular, the axis tilt is at 22.1 degrees, and precession favors a mild southern hemisphere, all at the same time, then it is possible that an ice age can be initiated. Landforms would have to be in the correct configurations, or greenhouse gases would have to drop low enough so that the ice age endures after the cycles change. The converse is also true, and Milankovitch cycles at the other extreme may pull the Earth out of an ice age. This is speculation for now, and it seems that ice ages are the results of landforms, mountain ranges, and greenhouse gases. Milankovitch cycles are reserved for producing glaciations and interglacials within ice ages. Due to relentless erosion and the movement of plate tectonics, the ice ages of bygone eons cannot tell us too much about the interglacial and glacial events. To get a better understanding of what is happening today, we now need to see what our current ice age can tell us about the expected climate patterns and possible abnormalities. Even most of the Cenozoic ice age reaches too far into the past to be helpful, so we will concentrate on the Quaternary, which began 2.6 million years ago. And keep in mind, available from all booksellers this coming holiday season, The Coming of the Seraphim. Thank you. Talk to you soon.